Hello, pre-calculus kids. This is Ms. LaFour, and today we're looking at 9-2 arithmetic sequences and series. So the arithmetic ones are really nice. I kind of like them because they're a little bit easier to figure out. So arithmetic just means you're adding the same thing each time, like or subtracting, if you're adding the same thing each time, then that's arithmetic. So notice on example 1 where it says, find the ninth term of the arithmetic sequence whose first term is 8 and has a common difference of -5. So that means they are starting with 8. Oops, I'm on the wrong thing there. Okay, we're starting with 8, and then we want to find the ninth term. So 1, 2, 3, 4, 5. 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay, so we want that term. And every time we are having a common difference of -5. So every time we have to subtract 5 to get to the next term. So instead of having to find all of these, if you understand what it is we're doing, you can actually use a shortcut. Now they got a formula up there, but I don't memorize the formula. I want you to understand what we're doing. So notice that I am starting with 8, and to get to the second number right here, I'm only adding or subtracting 5 once. Okay, so for each one of these, I don't know if you noticed, but to find the ninth term, all I got to do is take the first term and subtract 5 8 times. So this number right here is always one less than the number of term number it is. So this can easily be figured out by saying 8 minus 5 times 8 is 40. 8 minus 40, -32. So I don't have to find all of them to get there. I could, but I don't need to. If I recognize that it's always the first term and then plus your common difference, one less times than what you're looking for. So notice on the next one, let's see. Example 2. The numbers in the sequences below follow a general pattern. Can you write the general rule? So let's see if we can figure out what is going on. Now, the good thing is we know it's adding or subtracting something because it's in this section. Now, on the test, you may not know that, but if you have something with a decimal like this one, you might easily say, oh, look, I added 0.25, and I added 0.25, and then we added 0.25. You certainly can do that. Or you can think of it as a fraction and say, well, this is 1. This is 1 1/4. This is 1 1/2. This is 1 3/4. And notice, what are you doing? You're adding 1/4 every single time. You know, if you see it better as fractions, I'm figuring most people will probably see the decimals. But anyway, so we would say a sub n would be our first term, which is 1. And then we'd say plus our d, what was it, 0.25? n minus 1 times. So this is all you need, okay? You don't have to distribute it in and combine like terms. You can, you just don't need to. I'm not going to require it because this is how I think of it. First term plus your common difference, n minus 1 times. That's all it is. So let's look at part B. Here, notice from one to the other, what's happening? Yeah, you're right. You're adding 3 each time. And this has to be the same for this to work, obviously. So a sub n, any term, can be found by taking the first term, adding 3, n minus 1 times. Boom, we're done. Now on this page, we're looking at the sum of the first n terms of an arithmetic sequence. So this one's a little trickier, but it's still, you can either memorize the formula or just make it make sense. I prefer to make it make sense, okay? So notice here on example 3, find the sum of the first 100 natural numbers. 1, 2, 3, 4, 5, 6, all the way up to 100, okay? So some kid a long time ago, I forget his name, I should know this, okay? Somebody realized that, and this is how the formula came about, by the way, that if you add the numbers and go like 1, 2, 3, 4, all the way to 50, and then go across 51, all the way up, okay, This one would be 97, 98, 99, 100, okay? If we add the first 100 terms up, this would be 101, this would be 101, this would be 101, this would be 101, this would be 101. And so they realized that all we really had was 50 groups of 101. So that total would be 50-50. Okay, 5,050. And that's how the formula was actually figured out. Somebody's like, wait, we can use this on any of them. So our formula, which is that one right here at the top, see where it says this one right here, n over 2, because it's half of the group, right? If you whatever group of numbers you're trying to add, half of it, first term plus last term. So basically, if I want the first 100 numbers, it's 100 divided by 2, first term plus last term. And that gives us 50 times 101, which is 50-50, which is what we just found. So it's really amazing that someone was so bright and brilliant that figured out, hey, this works for all of them. And there you go. Memorize the formula or just understand the concept. Doesn't matter to me, whichever one works for you. Okay, example 4. The sum of the first 18 terms of an arithmetic sequence is 1404. If the 18th term is 124, find the first term. Okay, so this one's a little trickier. We've got more work to do here. We want to know the first term, but I know that they're telling us this is a sum. So the sum is 1404, and it's 18 terms, so 18. First term we don't know. Last term is 124. So basically I'm using the same formula, but I'm solving for something different. Instead of solving for the sum, the S, I'm solving for the first term. But we can do this. This would be 1404, that's 9, a sub 1 plus 124. All right, divide both sides by 9. We get 156 is equal to the first term plus 124. So if we subtract 124 on both sides, we get the first term is 32, and boom. We're done on that one. All right, so look at the next one. Find the sum of the first 15 terms of this arithmetic sequence. Okay, so they're giving this. We need to find the sum again. So we know the sum of these would be the first term. No, it says the total number of terms, 15. So 15 over 2. First term is 2 plus, the problem is I don't know what the last term is. They didn't tell us, okay? So we've got to figure it out, but no problem. We know how to do that. The 15th term can be found by taking the first term and adding the common difference 14 times. So what's our common difference? Well, what's happening from each one? Oh yeah, they're adding 3 each time, right? So this would be plus 3, only 14 times there, and so 2 plus, what is that, 42? So this is 44. So now I can add this into there, and boom. We can solve this. This would be 15 over 2 times 46, which would be 15 times 23, 345. So you're just using the formulas in lots of different ways. They're not straightforward. You do have to think. All right, so this one's a little bit more challenging. Example 6, find the sum of the finite arithmetic series. Okay, so this one tells us the first term, last term, but we just don't know how many it is. Like, what is n? You know, how many times is it there? So let's see if we can figure this out. Let's see. Okay, this is plus 5, plus 5, plus 5. So all of these are plus 5. So that means the last term, 99, is found by taking the first term, plus 5, n minus 1 times. So we can use that to figure out what is n. Minus the 4, that gives us, what, 95? And then we have 5 times n minus 1, so I can divide by 5. That's 19. Add 1, that's 20. Okay, so n is 20. Once we find that out, that helps. Okay, so that means our sum would be 20 over 2 first term plus the last term, and that's 10 times 103, which is 1030. Alrighty, so this next one, example 7, find the sum of the series. Yes, you can use your calculator on this one if you want. Okay, I'm totally down with that. Plug it in. Remember, you don't have to put a K, you can put an X there. Type it all in, make sure you get that. Math, it's under math, and then you tab down to the 0 entry that says summation and type everything in, and you should get 429. So just make sure you know how to do that, because I'm going to expect you to do that on the test, and it'd be a shame if you missed that one on the test. Same thing on example 8. You can use your calculator. Oh, look, they show you how to do it right there. Okay, so this one should be 432. So just do it. Make sure you can get there. Alrighty, so the next part. Find the missing numbers in the sequence. This is called the arithmetic mean. But if you're just knowing it's arithmetic, you can just use the same formulas and the same mindset to figure it out. Okay, so notice that my sequence here is going like this. Okay, there's 2 steps to 98. So the first thing I'm going to do is figure out, well, what is the difference there? So 98 can be found by saying 132 plus our common difference twice, because there was 2 steps there. So now I can just solve for D. So I'm going to subtract 132. That gives me negative 34. And then divide by 2, which is negative 17. Okay, so I know if I'm subtracting 17 each time, then that missing 1 I can find by just saying 132 minus 17, and that gives me 115. So that's the one that goes in the box. Now on part B, notice a little bit different. It's got 2 boxes we've got to find. So notice there are 3 steps there to get to 125. So I do the same concept. 125 would be equal to 80 plus our common difference 3 times, because there's 3 steps there. So subtract 80. That gives us 45. Divide by 3, that's 15. All right, so that means we're adding 15 each time. So 80 plus 15 is 95. That's the first blank. Add 15 again, you get 110. That's the second box that we're looking for. All right, so now we are looking at explicit formula, using explicit formulas. Find the 46th term of the sequence. So let's see what's happening each time. This is plus 3, yeah, it's plus 3 each time. Okay, so the 46th term can be found by taking the first term plus 3 45 times, because it's always 1 less. So 2 plus 135. So the 46th term is 137. That wasn't so bad. Okay, example 11. The number of seats in the first 16 rows of an arena form an arithmetic sequence. If there are 20 seats in row 1, 23 in row 2, how many seats are in row 16? All right, so the first one is 20, then it's 23, and we want to know the 16th row, way down there. Okay, so notice each row, since we know they're telling us it's arithmetic, that there are adding 3 each time. So that means the 16th row can be found by taking the first row, adding 3 15 times. So 20 plus 45, 65 seats in the 16th row. And the last one here, how many logs will be in a pile of timbered trees if there are 30 logs in the bottom layer? 29 in the second, and so on until there's 1 in the top layer. All right, so we have 30, then 29, then 28, then all the way to 1, right? Okay, so we want how many logs are in a pile. So we're looking for the sum. because it's the total of all the logs. So the sum, there's obviously 30 rows, right? So 30 divided by 2. First row has 30, last row has 1. That's 15 times 31, which is 465 logs altogether. Alrighty, there you go. You are done your notes for today.